what we will do next, I've shared with you a file. One of the files is deployment virtual WAN. This is an ARM template that deploy together, and it's going to create all the resource for our lab. So please find this file because we need it in a few moments. So basically what this file is going to create is all the pre-provision that you see over here. Beside this one is a mistake. It's not, the VMSS is not going to be pre-provisioned. We are going to create it manually, but it's going to create basically two spokes, spoke UA and spoke prod. Also, and I'm not sure we will have time for that, is going also to create a VNet for a single gateway. This should simulate an on-prem gateway. Behind this VNet, there is another VNet with a Linux machine. By the way, here we also have a Linux machine. So we will play with this Linux machine to simulate traffic. And we are also going to provision a checkpoint management server in another VNet. It's going to be published to the internet with a public IP. And I also created a virtual WAN with a single hub in West Central US. Okay, so everything we are going to do today on the West Central US. And of course, the NVA and the load balancer and the VPN, everything and all the peering was not created. We are going to create them together today. Okay, so let's move forward. And on the Azure portal, please search for templates. Okay, and we don't select template, we select deploy custom template. This is the one that we need to select, deploy custom template. So make sure you see the same screen. And now select build your own template in the policy editor. And I'm going to upload the ARM template that I've shared with you. So load file and select the template that I've shared with you. And click save. Resource group, create new resource group and give it any name that you want, lab workshop or VMSS or V1, whatever you want, and just change the region to West Central US. Okay, and after you just need to put a new resource group, West Central US, and we are ready to review and create the template. So my deployment is basically completed, but the V1 as part of the template, I'm creating a hub, a V1 and a V1 hub. And inside the V1 hub, so if you will go and look on a virtual WAN, you search for virtual WAN. This is the object that we are looking for. As you can see, I've created also the template also create a hub in West Central US. By the way, I just want to save you a few clicks, but creating a hub is super easy. Just click create. You fill some details, resource group, and so on, and the region, and this is it. It's creating a hub. I just wanted to save some time. And also, there is once you create the app, you also set an address space to the app. So it's need to be a unique address space that is not overlap with on-prem IP or other VNets. Now, if you will click on the hub, you will see that the routing status is provisioning. So we cannot move forward with any settings on the hub till the routing status will not change to provision. Sometimes on the first run, you are going to see that after 20 minutes, it's taking something like 20 minutes. You will see an error that it say that failed with a red icon. So you just need to click on reset router. Since it's not failed, this is grayed out. But if it's you get a failure, Just need to click reset router. It's going to take another 15 minutes or something like that, and then it's going to be fine. And in the meanwhile, while we are waiting, let's see the agenda for today. So I will give you a quick intro on Azure V1 and the new CloudGuard network security, the V1 integration with CloudGuard Network Security NVA, Network Virtual Appliance, that was announced as a GA just a week or 2 weeks ago. We will look on two reference design, common designs, and then we will continue with the hands-on lab, since it's going to take like 20 minutes for the routing to be provisioned. We will have to wait for that, and we will do the overview of what is Azure V1 and the reference design. So basically, Azure V1, it's a unified framework for networking, security, and routing using Microsoft Global Backbone. And it's a service that lets customers easily establish and optimize large-scale branch connectivity using Azure and Microsoft Global Network. And now we have the option also. So Azure V1, it's not something new, but the integration with third party, not just with Checkpoint, with third party appliance as a managed service inside the virtual lab. This is something new that was published just a week ago. So what kind of connectivity is allowed? So basically, branch to site VPN. It can be site to site VPN. It can be an express route, private connectivity express route, and it also can be an SD-WAN. They also support remote user VPN, okay, to terminate VPN clients, Azure Windows client or Azure macOS client, terminate it on Azure Virtual WAN on the VPN gateway. And of course, VNets. So we can connect all of our VNets in the same region or in different region to the virtual WAN. From routing perspective, as I told you, we are going to use intent route and inject the routes to all the peers, okay? If it's on the site-to-site, express route, the VNet, so we are going to inject the routes, and we are going to see it later on that all of the VNets, the spokes VNets, are going to get the default route to the internal load balancer. It's going to be configured automatically, injected. So all the route is going to be to the internal load balancer, default route to the internal load balancer in order to reach to the internet. So if this guy wants to go to the internet, his default route to the internal load balancer, the load balancer is going to pick one of the available CloudGuard. Let's say it's pick this one. We will configure hide NAT. Okay, for this packet he has an internal IP address. We will go to this guy, and this guy, the checkpoint gateway, is going to hide the internal private IP behind the gateway external IP, go to the internet, and the route back will go back to the gateway, to the internal, and from the gateway directly to the client. Okay, the route back does not go to the load balancer. Each one of the gateways has two network interface. One is external. It has also a public IP. So he has a external private IP, and off top of that we have a public IP. It is provided by Azure, and we have an internal interface leading to the internal network. And the checkpoint is going to learn all the peering, all the IP addresses via BGP that we are also created automatically, the BGP peering and the advertisement of the routes. It's done automatically, so you don't need to touch it. Routing between VNets and between VNet and branches. Also, we are going to publish all the the static routes of all the networks to the peering. So if this guy wants to talk with this guy, again, he's going to route it to the internal load balancer, from the internal load balancer to one of the CloudGuard. In this case, we are not doing that. The CloudGuard is going to send it over the peer to the destination, and the route back is going to be to the internal load balancer. Since the internal load balancer know about this connection, he is holding a hashing. You know that this gateway is handling this stream. So we'll send it to the same gateway. If he's going to send it to a different gateway, it's going to drop, right? Sending it to the same gateway, and the gateway will send it back to the client. Okay, so let's see what is the status with the hub. So it's still provisioning. So now it's a provision, and let me know, guys, if in your environment it's also provisioned. By the way, if it's on the last steps of provision and you will start to deploy the NVA or connecting VNets, it's also going to be fine. But if you start immediately once it's you created the hub and you start deploying NVA or do only all kind of route changes, you're going to get an error. So let's move forward. And now what we are going to do is deploy the NVA solution. So we'll go to Network Virtual Appliance. By the way, you have two options to deploy it. You can deploy directly from here. You will get a link to the marketplace, or go to the marketplace and deploy it directly from the marketplace. But let's do it from here. Go to Network Virtual Appliance. And click Create Network Virtual Appliance. And here you're going to see all the third-party virtual appliances that are supported. So they support right now SD-WANs, so SD-WANs appliances, and security appliances, like Checkpoint solution. Most of them over here right now are SD-WAN appliances. Select Checkpoint. Basically, once you click Create, you will be redirected to the solution on the marketplace. So we're going to leave to the marketplace. Okay, resource group. Create a new resource group. Give it any name that you want. CP NVA. West Central US. Make sure it's West Central US. And as I told you, this is a managed application. And we need to, you're going to see a managed resource group with this name that will be created. And we should, for the application itself, for the managed application, we should give it a name. So manage MNG app NVA or CP, whatever. Okay, this is the managed application. Give any name that you want. Click Next. Now we will select the virtual hub where we are going to deploy the solution. And we will give the NVA a name. NVA, CP NVA, it's good enough. And here you can see the scale unit. So how many gateways are going to be deployed. And this is based on the throughput that you need. We are going also to create a guide that will say that based on specific traffic bands and so on, what scale unit you need to select. Let's select the smallest one. By the way, suppose you select 2 units, and in the future you need 4 units or 6 units. What you're going to do, or even if you want to upgrade, so we don't support upgrade on the manage. What you need to do is deploy a new NVA, set a policy on them, okay, create them on the management, set a policy on them, and then just you change the intent route, we'll see it later on, to the new NVA managed application. Okay, so it's easy. So if you want to scale up or you want to to upgrade, this is the way to do that. Okay, so for the BGP, a private BGP address, you need to make sure that it's not overlap. And we're going to also to create a key pair, SSH key, to connect to those machines. So I will call it West keys. And I will move forward to the CloudGuard settings. We are going to deploy checkpoint version R8120. We support only one type of license, pay as you go on this deployment. Bring your own license is not supported here. I'm always changing to bin bash, the shell. The SIG, basically you can put whatever you want, but I've shared with you this file. So in this file, the SIG that I always use for my test is QWE123, QWE123. And he asked us if we want a quick connect to Smart One Cloud. We are not going to use Smart One Cloud. We are going to manage it with our own management. So click no. And basically, we don't have tags, so we can just click review and create. So make sure it's R8120. You will need to accept the terms. I agree to the terms and click create. And download the keys, the SSH keys. And this process is going to take like, I think, something like 10 minutes. Okay, while it's being deployed, let's duplicate the tab and let's connect. I want to connect with Smart Console to the management. So I will on the new tab. So keep this one open so we'll see when it's finished and if it doesn't have any errors. And on the new tab, search for virtual machines. And I want to find what is the IP address of the checkpoint management. So make sure you see this, the CloudGuard MGT. This is the management. And click on it and you will get the public IP. So we have the public IP, copy the public IP, your public IP. So again, virtual machines, CP, MGT. And click on it and copy the public IP. And I will open a Smart Console. And the password is the password that you see over here, checkpoint machine. The username is always admin. And this is the password, capital L. So just copy paste it, okay? So while we are waiting, let's move again to the reference. And this is another reference architecture where we have and also SD-WAN connectivity. Now, the reason that we have two hubs in the same region and we don't have just one hub is that currently Microsoft Azure does not support to put different third-party appliances in the same hub. So this is why we need to separate it into two hubs. So there is a one hub that is terminating the SD-WAN, where we place the gateways, the SD-WAN gateways, whatever solution it is. And all the branches are terminating the connection on the SD-WAN appliances. And if traffic wants to go from the branches to one of the spokes, is going to the SD-WAN gateway, inspected on the hub, and go to the final destination. You need to bear in mind that if you have, for example, this spoke that is connected directly to the SD-WAN hub, traffic between this spoke and the branches is going through only through the hub one, okay? And it's not going to be inspected over here. So this is the connectivity that you need if you have an SD-WAN solution. So what I want to do now is to start creating the machine. Let's see if so it's still it's a deployment on progress. So on the Smart Console, let's prepare the object. Let's create a new network object, and let's call it spokes. And the IP address for the spokes is 192.168.0.0. And let's take a class B. So 255.255.255.0.0. It's going to cover the spokes. Okay, so I created the spokes. And for the NAT, basically we have two options for creating a NAT. So we can create a NAT in this way. Just click the Add the Automatic Address Translation. So we can use it this way, or we can use create a dynamic object, local gateway external, okay, and create the rules manually. I will use Add Automatic, and a NAT rule is going to be created automatically. So if I go to the security policy, to the NAT section, we see that rule 3 and 4 created automatically. So there is a hide NAT, okay? You can see from spoke to any is going to be hide behind the firewall IP address, external IP. And there is no NAT between the spokes. We don't want to do any NAT. So we are going to keep the source and destination original. Now for the policy, let's create an any accept. So we will use the cleanup rule. Just remove it, the name, any accept, and just I want to log the traffic, and we are good to go. So let's publish the changes. And let's go back to the gateways and servers, and let's see if the deployment, yeah, so the deployment is complete. And now to see it, go back to the virtual WAN. Click on the virtual WAN. Click on the hub. So you can have multiple hubs, right? We have just one hub, and we deploy the NVA inside this hub, right? In West Central US. So I will click on the hub. And inside the hub, I will scroll down to the virtual network appliance, and I'm going to see the NVA. Okay, so this is the managed application. And per my selection, it created the two appliances. So if I will click here on click here, you will see the instances, and each instances, as I explained to you, has two network interface. One is internal, and one is external. The one with the public IP is obviously an external. So he has an external private IP and external public IP. What I want to show you, so we are still waiting for the others to complete. So let's take a look on one of the virtual machines. So if we are if we are looking on this virtual machine, the Spoke UA, on this Linux machine, we want to see what is the effective route. How do you see what is the effective routes on a virtual machine? You need to go to the virtual machine, and the effective route, you're going to see it on the network interface that is attached to this machine. To get to the network interface, you need to select the machine, go to networking, and select the network interface. Under the network interface menu, you're going to see effective route. So please do that. Go to virtual machines and select the prod or the QA. It doesn't really matter. I want to remind you that we haven't created the peering yet. So this is a standalone like VNets that are not paired with the global one, but I want to show you what are the routes before we create the peering and after we create the peering. So I select the QA. On the QA, I will click on the networking. And you have the network interface. You see the network interface. Click on the network interface. There's only one network interface. And scroll all the way down to effective routes, not effective security rules, effective routes. So again, effective routes you can see on the network interface. What we are going to see now is the default routes. Those are like the system routes. So the system routes that we are going to see is to the network itself. This is the subnet of the QA. Okay, 192.168.1024. So this is the virtual network. You know how to reach to IP address inside this virtual network. This is a system route. And he also has a default route to the internet through Azure backbone, directly to the internet. Obviously, if he will try to ping to the internet, he is not going to succeed because he doesn't have this instance, does not have a public IP. If he would have a public IP, it would have been successful, but he doesn't. If you want to test it, you can open a serial and try to ping to the internet. You're not going to be succeeded. And all of those routes that you see, all of those routes are system routes, and they are going to be disappeared after we are going to push our intent route. Okay, so take a look on the route table. This is how it looks. And while we are waiting, we can make the connection between the spokes to the hub. So to do that, we are going to, let's say, duplicate this tab. So we have this tab open because we are going to watch, to refresh the table and watch what is going on the effective routes. So we'll duplicate the tab. Please duplicate also the tab. And we are going to connect the spokes, the two spokes, the QA and the prod. Those two spokes, we are going to connect them to the hub. Again, we are going to the virtual one. Go to the virtual one. Click on the global one. And we are doing the connection. We don't need to go inside the hub to make the connection. We are doing it from here, from the connectivity. So click on the global one and we have connectivity. And select the virtual network connections. So this is for VNet connection, virtual network connections. As you can see just one hub, and there are no virtual networks connection to this hub. The number is 0. And we are going to create two connections. So click add the connection. So the first one is going to be, let's connect the prod. So prod peer, or whatever you want to call it. Prod peer. We'll select the hub, to which hub we are going to do this connection. We are going to select the resource group of where the VNet is located. So the VNet is located inside the lab workshop where you deploy the template. So he's going to look inside this resource group and look for all the virtual networks that is being deployed into this resource group. And I'm going to select the pod, spoke pod. Okay, so I'm creating the second peer. It's going to take like a few minutes. And while he's creating the peering, you know what, before we do that, I just want to remind myself that I want to refresh the route table. So I will refresh it. You don't need to do it. I will refresh it on my screen. So if the peering has been created successfully, you are going to see that he is going to know about the hub. So he doesn't know about so he know about the hub. So this is the hub IP address space, 10.0.100 class C. And we didn't push any routing. So just created the peering for now. And by the way, after the peering has been created, you will have access from this spoke to this spoke. It's not going to be inspected, but you will have access between the spokes. So let's just make sure that it's working. So on the virtual machines, go to the virtual machines. And select the QA app. And scroll all the way down, you have a serial console. Now the username, wait a few moments, the username for the Linux machine is admin user. You see it over here, and this is the password, the LY. So admin user. And now let's IFA config. The IP here is 14. So 14, and the port is 04. 192.168.04. Okay, and I have ping, I can access it. If I will try to access the internet, it's not going to work. Okay, so since I create the peering to the hub from both spokes, they can talk with each other. Spoke UA and spoke prod can talk with each other. So just verify that it's working for you, and we will move forward to configure the NVA gateways.
Want me to stop
Yeah,
share?
so
Okay.
he learned, this is the QA, he learned how to reach to the pod. So it's reached the pod via the virtual network gateway. The last step is basically, or two steps we have, is to configure the NVA in the checkpoint management. So I'm going back to the network virtual appliances. I want to remind you that you go to the hub, and inside the hub, we have the network virtual appliances. And you're going to see the instances IP. So basically, we've created a script. So if you have two options, you can create them manually in the checkpoint management, or you can do an automation. If you have like many gateways and you don't want to do them one by one, I can share with you a script that we've created. This is a Python script. There is a JSON file that you will need. So this is a JSON file. You can put your management IP, the tenant IP, client IP, subscription, the manage app resource name, the username to log in to the checkpoint management, and the policy. And is going to configure this script, is going to create the object, the checkpoint NVA object one by one on the checkpoint management, and install a policy of them. But since I'm not sure that each one of you have a Python, so we're not going to use this automation, I can share with you this script, and we are going to create it manually. So please open it, copy, you don't need to copy, just make sure it's open. And let's go to Gateway and Servers and create a gateway. You can use the wizard mode or a classic mode. I will use the wizard mode. So this is a CP NVA 0. And the gateway platform is CloudGuard IaaS. And put the IP address of the first gateway. And the SIG, this is why I told you to remember the SIG and use the SIG that I use. This is the SIG. I'm going to repeat the same process with the second one. And again, if you have many of them, you can just use the script. What you need to remember that on the cloud, when you deploy gateway on the cloud, you need to remove spoofing. So click on one of the gateways. You need to do the same process to both of the gateways. I will start with NVA 0. Click on the network management, and you will see the network interface, the external and internal. We need to remove spoofing from both interfaces. So click on ET80 and click on the topology modify and remove the spoofing. Perform anti-spoofing, we remove it. I'm going to do the same to ETH1. The internal one, click on it. On the topology, click modify and remove the spoofing. Okay, and click OK. And I'm going to do the same process also for the second gateway. And on the first deployment, for those of you that are not familiar with that, we cannot deploy on the first deployment or the first installation. We cannot install the threat prevention policy. We need to remove it because for policy, it's going to fail and it's going to say to you that you need to install the access control rules first. So just make sure the access, the only one that is selected is the access, and install the policy. So basically from the checkpoint side, we're ready. So let's just switch to the logs and let's filter the logs. So the logs will be ready once we will start to generate the traffic. So click on the logs. And once you are in the logs, on the search box, write type source, SRC, and 192.168 dot asterisks, and we are going to filter only traffic that will come from a network 192.168. We want to see only traffic from there and click on the auto update. Okay, so when traffic will come, we are going to see it almost immediately. So we are ready over here. So again, what we are going to do now is basically we are going to create intent route, and we are going to enforce a default route for all the peering. Default route will go to the internal load balancer, and from there it's going to go to the CloudGuards, and also traffic between internal networks, all the 10, 190, 192, 168, 172.16 also is going to be routed to the CloudGuard. How we are going to do that? From the Azure portal, we are going to route intent. You see, routing intent. So it's inside the hub, routing intent. and we are going to say that internet traffic will go to network virtual appliance, and we'll select our NVA. By the way, you can have a list of many NVA over here, so you can select to which one you want to route the traffic. And also private address is going to the network virtual appliance to the NVA. Once you make the changes, don't forget to click Save. We'll wait. It's going to take like 2 minutes. And first, I will want to see the effective route. So I will wait for it to be completed, and then I will refresh the effective route on the QA NIC. Okay, so this is the route before the change, and let's wait for it. I will refresh the routing table, the effective routes, and let's see the effective routes. So you can see that all the system routes is not here anymore. So you can see default route that we publish is going to the virtual network gateway, which is the load balancer, and also reaching network 16, 10, 172, everything go to the NVA right now. Okay, east-west traffic, internal networks, go to the NVA. Now, if you will go and you want to see the route tables over here inside the hub, sorry, effective routes, click on the effective routes, network virtual appliance, and the CPNVA, and let's see what does he see. He's going to see the spokes, how to reach to the spokes. So you see, you know about the spokes IP addresses and also default route to the internet. Now, let's try to run the same test that we've done. Disconnected. I will try to connect again. I connect with serial console to the QA machine, and I will run ping to the internet and also ping to the prod. And this time, we should see the traffic over here on the log. So we should see that it's going to the checkpoint. So I will run a ping to 888, which is working right now, and to 04. And this one works because it's going to the NVA, right? Because it's doing high NAT. Before it was not working. So I know it's going to the NVA. And also I have a ping, but this one I had before. So to verify it, check the logs, and we see one log ping to Google DNS, and another one is with traffic from QA to the pod. What we're going to do next is basically we want to publish application. As I told you, from the hub, we cannot publish application to the internet. It's not supported. We're going to create a skill set. For working with VMSS, we need to configure the CME Cloud Management extension on the checkpoint management. The reason that we need this service, VMSS, scale in and out automatically. So it's creating, based on the load, it's creating more gateways, and if the load decrease, it's delete the gateways. And since this is an automatic process that is being handled by the cloud provider, we need the process on the checkpoint side that will create new instances, configure them, install policy on them, and delete them once they are being deleted. So the CME process is responsible for that. So please open an SSH session to the checkpoint management. Now with R80 120, it's coming out of the box, the CME service. To make sure that you have it, you can just run the command service CME status. Okay, and you see that the CME is running. If you don't have a CME, you can install it, or you can go to user support center and download the CME and install it. But with this version, it's coming out of the box. How do we configure the CME? Everything starts with autoprov_CFG. We do an init command for Azure. We put MN, it's for the management server. We need to say what is the management name for the CME. It's not related to the object that we have over here for the management, okay? Not related. It's a completely different name, just for the CME. We do it one time, and then we create a template. So what we have on the template, so we have the one-time password, we have the policy version, what is the version of the gateway, and what policy to install on it. And this part, the CN, is for the controller. So we can have many controllers for many cloud providers. And for the controller, we give the subscription ID. You need to access Azure, so you need the subscription ID, you need the directory ID, the application ID, and the secret, and replace it. After you do that, I recommend you to have it on one line. Do it with Notepad++ and copy it from end to start, like that. Okay, I copy it. And we'll go here and put it over here. He asked me if I want to restart the service. I don't want to restart the service. No, because I want to edit the template. So for example, for the template, and you have here how to set, for example, we can set for the template, this is one of the parameters that we can set. We can activate IPS and the identity awareness blade, for example, and also application control. There is an admin guide for CME that explains all the parameters and everything. So search for a CME admin guide and you will have it all. But this is and you can add many templates for different deployments. So I will copy it, I will paste it here. And now I can restart the service. And now, after it's restart, to test that the controller can communicate successfully with the cloud, I will run the command service CME test, service CME test, and I should not get any errors over here. So I didn't get any errors, so in my environment, everything is good. So we configure the CME. Okay, now we are ready to deploy the template. And when we deploy the template on Azure, we will use the parameters that we created on the CME, the template name, the SIG, everything need to be matched what we have here, because it's going to tag the object, okay, with the management name, with the template name. It's going to tag the skill set parameters, and this is how the management is going to know that he has a skill set that he needs to configure, a VMSS that he needs to configure, and he know which parameters to use. So going back to Azure, we'll go to Marketplace. And we will look for checkpoint. And we need this object, CloudGuard Network Security, Firewall and Threat Prevention. And click Create, and we choose here CloudGuard skill set. So I'm waiting for you. Please get to this point. We'll put it in a new resource group. By the way, checkpoint, when you deploy checkpoint for Marketplace, you cannot deploy it into an existing resource group. So resource
Which
group.
one did you select?
I'm saying, just explaining that if you deploy checkpoint products and you try to deploy it into an existing resource group, okay, whatever resource group that you have that is not empty is not going to allow you to do that. You always need to create a new resource group. CP VMSS, give it any name that you want. West Central US. The skill set name CP skill set or VMSS. The password, let's use the same password that we are using along this workshop. Moving forward, we are not upgrading the VMSS. He asked me how many minimum instances of gateway we want for the skill set, 2, and what is the maximum 10. You can always change it later on up to, I think, 1000. The management name, is not the checkpoint object management name. It's all those fields are referring to the CME. So the management name is this one, MNG. Copy it exactly as you put here. So this is the CME. And because it's going to tag the scale set with those parameters, management name, configuration template name, okay, and copy the template name as well. US West is the template name. For the load balancer, as I told you, we don't need the internal one. The internal one is like this, acting like this one, only for outbound traffic or east-west traffic. Here we just advertise from the external, okay? Just publish application, so we don't need the internal one, just external only. Inbound inspection only. The load balance just session persistency, you can change it, play with it later on. Those fields are not important. Deploy load balancer with floating IP. We don't need it. You can read about it also in our documentation. What is important is deploy the VMSS with instance level public IP address. We need it. Click yes. Why do we need it? Because we are going to manage those gateway over the internet. Our checkpoint, we don't have like a VPN or something like that. So we're going to manage them over the internet, and for that they need public IP. So we need public IP. We don't need a prefix, a specific set of IP addresses. Deploy the VMSS instance with public IP address, yes. And the management interface is going to be, and this is also very important, the front-end NIC public IP. Front-end NIC public IP, okay? We access it over the internet, okay, to the public IP address. So those are the settings that are important, and we can move forward. And we select the version RET120. With the virtual machine size, we are good with that. By the way, you can change it later on, change the machine size that you want for the instances. I'm always changing the admin to bin bash, and the C key need to match what we have over here on the template. The OTP is the SIC, it need to be matched, right? So once we run the template, it's configured them with D6. So the CME is going to try to configure them with the SIG that he has on the template. So it's need to match. Moving forward to the network, it's going to create a new VNet. You can change the name, but as long as it's not overlapping, we are good. 10.1, 10.1.0.0, 10.1.1 for the front end, for the back end. We are good with those settings, so we can review and create. So validation pass, and we can click create. Now, if you want to see how does it work, the CME behind the scenes, I've also added you the command over here, tail-f, and this is the CME log. So copy this command, the tail-f, and run it in the management. So you're going to see the CME cycles. Okay, so it's going to take like a few minutes, and the CME is going to see is query Azure all the time, and he's going to see a new VMSS that is tagged with his management CME management name and the template, and he's going to see that he has 2 new instances, and he will try one by one to configure them to create. You're going to see here in 3 minutes, you're going to see the new instances, and he will try till the SIC port will be open. He will try to add him, and then he's going to configure them with the blades, and then he's going to push initial policy and then the standard policy. By the way, the policy that we put here on the CME standard need to match the policy that we want to install.
Did you hit create?
Yeah, of course I hit create, yeah. So here you can see the two Azure instances. Okay, you already see the two Azure instances. And now we'll try to open a connection. So it's going to take from them a few moments because he's running the first time wizard behind the scenes and so on. So he's trying to open a connection. Once it will open a connection, you will enter into adding state, and you will see it automatically being created on the gateways over here. So let's wait. I will put it like that, and you will see it. You see that the SIG port is now open between the management and the first gateway. And now he's entering adding state, and you can see that he's adding the gateway, the first gateway. He's installing the initial policy on it, and then he's going to deploy the standard policy. The reason that we put this policy because we cannot install threat prevention policy. So we create a basic policy that has a management access to it. And then we push the standard policy with the threat prevention policy. But never use this policy to deploy on your gateways. And now you're going to see that it's going to add the blades. We select identity awareness, right? IPS, and now it's going to deploy the standard policy. The policy that we select as part of the CME is going to finish this process. After you finish this process, is going to enable port 8117. So the load balancer, the health probe, is configured to send probe on TCP 8117. And it's going to be open only after the standard policy is going to be installed. And now it's going to listen, the load balancer is going to see it as an active member and start sending traffic to this member. And now he's going to do the second one is going to configure the second one. You see already he didn't edit. We'll have to wait for it. Now he's going to adding state. We're going to see another gateway. See another gateway, and he's going to configure it the same way. If a new gateway will be added, he's going to add it. If a new gateway will be deleted, he's going to delete it also from the management. Okay, so make sure that you have it also on your environments. So again, if you are going to a virtual machine scale set, VMSS, you write
Yes.
here VMSS, and you click on the VMSS, you go to tags, and you see all the tags, okay, that was part of the wizard. This is how the CMEs access and know how to configure it. So you see this checkpoint IP address needs to be public. Anti-spoofing, you disable anti-spoofing. This is not part of the wizard. This is something that we are doing behind the scenes. The management, you see the CME management name that we put. How does it manage the interface on 8080? 8080 is the external one. So, and the template name need to match what you have on the template.
Yes. Same for me.
Same for you.
Same on my side, the same like you.
And you run the service CME test, and it was working fine.
It's show me only the subscription IDs and so on.
You didn't get any errors when you run it.
No.
So
Go
if
try
you
it
cannot,
again.
so if you cannot share, it's a problem for me to help
Yes.
you.
Yeah, understand.
But try to solve it. You can play with it. It's not, as you see, it's not very complicated. What else? No idea. I ran it many times. No issues. Okay, so now what we want to do after we have those two gateways, we need to connect the peering. Let's connect the peering. Okay, so we are going to the hub. We are doing it from the global WAN, right? Virtual network connections, and we are going to connect the hub, the VMSS, VPC. So we have two peering to the spoke and to the prod, and we are adding the third one. And this is for the VMSS peering. Select the hub. Select the resource group of the CP VMSS and the virtual network, VNet1. Click create. Okay, and now also the VNet 01 is connected. But now we have a problem. If you'll go to, did you make the connection to VNet 01, all of you? If you try to install policy on the scale set, it's going to fail. Let's try to install it. It's not red, but we lost the connection to them. I'm telling you. Let's try to do that. It's going to take some time till he update it, because he's trying multiple times. By the way, he changed the policy target only to the VMSS, but let's just try one of them. You will see that he's going to fail. And I want to ask you, what is the problem that it's failing? He's not going to succeed on installing it. We lost connection. You see, we lost connection to both gateways. What is the reason that we lost connection from the management to the gateways? Try to think of it. When did it happen? Once we created the peer, we lost connection from the management to the VMSS, to the public IP address of the VMSS, of the gateways over here. What is the reason for that?
It's because of the default route entry.
Yes. So we publish, you remember, we publish an intent route to all the peering. We publish default. We publish default also to this network, okay? We publish default route. So these gateways are not going to the internet from the system route. You will try to go to the internet from here, okay? From here to here. It's going to hide them, okay? You cannot communicate with them, okay? So what we need to do here is create a UDR, user-defined route. There is a route table that they associate with the external subnet and also with the internal subnet. We are going to edit the route table that associate with the external subnet, and we are going to create a static route 0000/0 that point on the internet, okay, directly to the internet. So on the Azure portal, you see policy failed and I lost access. So on the Azure portal, I will go to UDR, user-defined routes, or route tables. And this is the, you see, this is the VMSS resource group, and I have the backend and the front end. We are talking about the front end. On the front end, so custom route that I create is a higher priority than a routing that is coming through the injection. So I'm going to the front end, routes, and I'm going to add route to the internet. So this is going to be a default destination IP, and it's 0000/0. And the next hop is going to be internet. Okay, so I've added the route table that associate with the external subnet. Okay, route directly to the internet. So it's going to take like a few moments to get to be effective, and I will switch back here. And also here it's going to take a while, but if I will install policy now, it's going to work. It's going to be very fast. We don't need to wait for the.
I lost you on the route tables.
I will show you again. I will just show you that it's working. Let's put policy and I will show you again. So now everything is good, back to normal. So now, what else do we need to do? Now let's think about the packet flow. So we have a user that is over the internet. You want to reach this guy. Let's see if the machine is still alive or it's completely stuck. Let's go to the QA. Serial console. I think it was working for me. So let's see. Let's run curl 127.0.0. Yeah, it's working. I have a web server on it. I can publish it. You can publish 22 if it's not working for you. But so we have a user. He's coming from the internet. He's going to hit the external load balancer. As part of the deployment of the VMSS, there is an external load balancer. You remember, we deploy external load balancer. And The load balancer has a listener. This is a network load balancer, by the way. You can also deploy a application load balancer if you want, but we deployed as part of the template network load balancer. So let's see what we have on the network load balancer. Let's switch and let's search for load balancer. And this is our load balancer. And the load balancer is coming out of the box. We configure it with public IP, and you can add many front public IP over here. But for our use case, we just need one. So this is the public IP that the user, we can create an A record, but we're going to use the public IP. So the user is going to put this IP on the browser, HTTP, and this IP or SSH. The backend pool, we configure it automatically. It's it's the scale set. It's the IP addresses that are coming in and out automatically. As I told you, each one of them is listening on port 8117. This is for the health pub. Also, we configure it automatically. As part of the configuration, we also create a load balancer rule, and you can create many rules. So in order to publish many application, is listening on port 80. Okay, so the user will access the front-end IP on port 80, and we send it to the backend, which is the checkpoint gateway, on a different port. So he is listening on port 80, and we send it to the backend port on port 8081. Okay, you can keep it also for the SSH if you don't have a web server. You can access it over port 80. So let's keep it like that. So remember that the load balancer listening on port 80, and is going to send it the traffic to the gateways on port 8081. So let's configure the checkpoint. We need to configure the NAT policy, right? Because here we have any except. We don't need to configure anything. It's all about NAT. So let's create a NAT rule above that's saying the traffic that coming from all internet. The thing is that this is an application load balancer, network load balancer. Network load balancer, when they send the packet to the gateway, is going to preserve the original source IP. It's not changing the IP. So I'm not putting the load balancer IP here. I'm putting all internet. It's coming, the checkpoint sees the original source IP. So it's coming from the internet. And the destination is local gateway external. We need to create an object that is called local gateway external, because we cannot put the static IP of this object, right? Every time the load balancer is going to send the traffic to a different network interface. So we're going to create a dynamic object. So please do that with me. New, more, network object, dynamic object, dynamic object. And basically we need to create two objects. One that is going to represent dynamically the external interface, and one that is going to represent the internal interface. I will explain you in a moment why we need the internal one, but let's focus now on the external one. So dynamic object, and we're going to create an object, and you need to spell it exactly like I spell it, with the capital L, local, capital G, gateway, external with capital E. And I want to create another object because we will need it later on. Again, so more, network object, dynamic object, dynamic object. And this time we're going to create a local gateway internal. Now I want to create also, I will create the QA. The QA is 1.4. I will create this host 1.4. Create a host. QA 192.168.14. 192.168.14. So we've created the object, the local gateway, the dynamic object, local gateway external and local gateway internal, and also the QA object. And now the original is going to come from original source. Where does it going to come? To the local gateway external. Once we compile the policy on the gateway, each one of the gateway is going to get this policy of the NAT policy, right? And is going to compile it and put inside. So this gateway, once is going to get the policy, is going to put his own IP address inside the local gateway external. When this gateway is going to compile the policy, is going to put his own IP address inside this dynamic object, okay, local gateway external. Traffic will come to the local gateway external on which one of the object, on which service. The load balancer is going to send it on port 8081. Okay, we have this port already, I think. Let's let's use for the load balancer, let's use 8080 because I don't want to create a new port. So let's use 80, send to 8080, okay? So we will update it, send it to 8080. Okay, so we'll use 8080, an existing port. This is a HTTP proxy. And now, so packet is coming from the internet again to the load balancer on port 80. The load balancer is going to send the traffic to the gateway on port 8080. And now we want to send the traffic over here with the, not with the original source IP of the user, right? Because if we send it without changing the source IP, is going to get to this Linux machine, and is going to send the traffic back to the cloud one over here to the internet. How to fix it? We are going to hide the packet behind the internal IP address of the scale set. And for that, we are going to use translate source to the local gateway internal. And what we need to change by default is doing a static NAT, and we need to change it. So right click on it and change the NAT method to hide. So we are going to change it to hide NAT. And we are going to send the packet to the QA machine. And we are going to translate the service. At which port does the machine is listening on? The QA machine is listening on port 80, right? Okay, so traffic coming from the internet to the local gateway external, to the network, to the external interface of the checkpoint on port 8080, because the load balancer is sending it the traffic to the checkpoint on port 8080. And now we are going to translate the source to the internal interface of the VMSS. And we translate the destination to the QA machine. And we translate the service from HTTP from port 8080 to port 80. So let's say install the policy. And this way we can create many applications behind the firewall, but each one of them we need to publish them on the checkpoint on a different port number. So we have many ports, we just need to create TCP ports. And for each one of them, we are going to create a dedicated port. So let's install the policy. And let's take the external IP of the load balancer, which is this one. Let's see if it's finished. It's not finished yet.
Hey, Shay,
Yes.
do you know if Global Gateway Load Balancer is GA yet for Azure?
Yes, it's GA, but it has some limitation if you're familiar with that. Yes, GA. All right, we have a LAMP server. I think we didn't have to install anything. We had an HTTP server on those machines. I'm not sure. Anyway, try to do that by yourself. This is the rule that you need. This is the most complicated part that you need to understand. So we saw east-west traffic. We saw ingress and egress traffic.